Hi and Assalamualaikum. My name is Muhammad Daniel bin Muhammad SAHID and I am from Group 2, and today my team and I will be present you about our CSC510 project named Set Relation Calculator. And our team consists of 5 members.
Hi, my name is MAISARAH YASMIN. Next is background study. The members of our team have agreed and decided to settle on question number 2, which focuses on the set and properties that include reflexive, symmetric, and transitive. The goal is to create a program to determine whether the input of a relation set meets the reflexive, symmetric, and transitive properties criteria. To able to generate the reflexive closure, symmetric closure, and transitive closure for the set and relation. Next is program and software. Developing the program in C++ programming language with an application software called DEV C++. It is non-GUI program for the user interface. Okay, next is a problem statement. First is difficulty on how to identify which properties of relation should be used, mistakes on resolving the relation of the given set, a lot of time consuming when answering questions manually.
For the demonstration part, there are 2 cases that will be demonstrated based on the sample input shown in the slide. So the first case is about sample input of set elements that satisfy 3 properties of relation, which are reflexive, symmetric, and transitive. And for the second case, we are going to use the sample input that is not satisfy these 3 properties. So let's move to the demonstrations. This is the full code for our project. So let's try to run this code. So we need to enter the numbers of elements in the set based on the simple input. So we have 1, 2, 3, 4. So we have 4 elements. So just like 4. And then we need to enter the elements of the set. So 1, 2, 3, and 4. This is for case 1, yeah. And then we need to enter the number of pairs. So we have 6 pairs based on the simple input. And then we need to enter the pair. So pair 1 is 1, 1. Pair 2 is 1, 2. Pair 3 is 2, 1. Pair 4 is 2, 2. Pair 5 is 3, 3. And the last pair is 4, 4. And then it will list all of the output. So the set elements is reflexive, symmetric, and transitive. So the conclusion is the relation is an equivalent relation because it satisfies the 3 properties. So this is for the case 1. So now let's try to run for the case 2. So we need to enter the numbers of elements in the set based on the sample input. Our element is 1, 2, and 3. So the numbers of element would be 3. And then we need to enter the element 1, 2, 3. And then we need to enter the numbers of pairs based on the sample input. We only have 2 pairs, so 2. And then we need to enter the pairs. Okay, so the first pair is 1 and 2. The second pair is 2, 3. So we will get the output. So the relation is not reflexive, it's not symmetric, and also not transitive. And then the program will also shows the closure for these 3 properties, and it will display the conclusion as well, which is the relation is not an equivalent relation because it's not satisfy these 3 properties. I think that's all for the demonstration parts. Thank you.
User analysis for the case 1. Okay, input from the user for the set A are 1, 2, 3, 4, and the relations that being created are 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. So that's why the output of the system come out with the relation is reflexive, symmetric, and transitive. So the relation is reflexive since it have the element of AA inside of relation. We can see here, we have 1, 1, we have 2, 2, 3, 3, and 4, 4. That's why it can consider as reflexive relations. Then the relation is symmetric. Is because AB element of R, BA also element of R. you can see in the relations 1, 2, element of R, 2, 1, element of R. So that's why this relation is symmetric. One relations can be considered transitive if AB element of R, BC element of R, and AC also element of R. So it can be seen in these relations in 1, 2 element of R, 2, 1 element of R, and 1, 1 also element of R. So that's why this relation is transitive. For the case 1, the input that being inserted by the user come out with the output reflexive, symmetric, and transitive.
As for the result analysis case 2, input from the user for set A are 1, 2, 3, and 4, and the relation that been created are 1, 2, and 2, 3. So the output of the system are the relation is not reflexive, not symmetric, and not transitive. To be considered as a reflexive, every element of AA need to be in element of R. In this case, R is not reflexive since 1, 1, 2, 2, 3, 3, and 4, 4 is not element of R. Next, the relation is not symmetric because AB is element of R, but BA is not element of R. As we can see here, 1, 2 is element of R, but 2, 1 is not element of R. So, that's why the relation is not symmetric. And lastly, the output is not transitive. To be considered as transitive, AB, BA, and also AC need to be element of R. But as we can see here in the relation, 1, 2 is element of R, 2, 3 is element of R, but 1, 3 is not element of R. Therefore, the relation is not transitive.
In conclusion, identifying the correct type of property relations is crucial to obtain accurate results. However, this process can be challenging since many relations appear similar. Developing a program or system to address this issue can save time and make it easier to determine related properties. For future applications, this program can be expanded and adapted to real-life scenarios, where understanding and analyzing complex relationships are crucial, such as in data analysis, engineering, and mathematical modeling. To sum up, we believe such program or system will benefit many people facing difficulties with property relations and contribute to creating a better mathematical environment, especially for those in this field.